It's good to remember that in our macroscopic world we have all sorts of energy. Probably since you woke up, you have used all sorts of energy. There is mechanical energy. You may not know that you have used nuclear energy, but a fair amount of our electric energy comes from nuclear uh, power plants. Chemical energy, if you turned on your car, electric energy, probably your laptop or your computer where you're watching this may be running on batteries or just plugged into the electric. Thermal energy, if you have a heater running, or you can feel the heat, the warmth from the sun, etc. Okay, it's obvious that there is gravitational motion, sound. So in the macroscopic world, there is a, a very diverse forms of energy. But what we just said before is that in the atomic world, there's only two forms. In the atomic world, there's only two forms of energy, which is the kinetic energy and the potential energy. So all these forms of macroscopic energy have to be reduced at the atomic level into either kinetic, potential, or both. So it's important what I just said, right? That there is some of these um, microscopic forms of energy that have their origin in the kinetic energy of the particles. Of course, your heater feels warm because the particles that your heater is made out of move faster. Okay, the same for a truck driving. It's that the particles of the truck that are actually moving faster, etc., etc. And again, a little bit more intricate because it requires a better understanding of the molecular world is how to see that some of the macroscopic forms of energy have an origin into the potential energy of particles, like chemical. We just saw that reaction that could be used as fuel. That explosion, if you put it into a turbine, can be used as fuel. So that we were using chemical energy. If you have a stretch spring, of course, that you are actually stretching some chemical bonds or intermolecular interactions of your spring, therefore the original of nuclear energy. So it's good that we keep this connection between the macroscopic and the atomic because it will give us a very good perspective because chemistry after all is the study of the atomic world, so we have to be able to transform microscopic observations into atomic explanations. That's an important aspect.